es jetzt an? Okay, okay, okay.
Hallo.
Hallo, hallo. Ja, man hört es. Man hört alles.
Hallo.
Okay.
Hi. Hallo.
Hallo.
Ja. Na, Ender bitte in die Kinderabteilung. Ender bitte. Der kleine Ender möchte aus dem Smallland abgeholt werden.
Welche Nummer hast du? Das ist die Nummer 2, wa? Sprich mal.
1, 2, Huen. Okay, das ist schon ziemlich laut. Test.
Hallo.
Nee, ins Rote sollen wir nicht dann übersteuern, die meistens. Besonders wenn man die aneinander hält. Also genau 1 unter Rot.
Okay.
Hallo.
Du kannst die Lautstärke auf der Bühne, Saal.
Saal Lautstärke geringer machen. Nee, Saal darf ja leiser sein. Bloß Abnahme hätten wir gerne laut.
Hallo. Hi. Hallo.
Test, 1, 2, hi.
Ja, passt das?
Wird schon gehen. Sie soll mal drüben sagen, wie laut das jetzt war.
Test, test, test. Hello. Hello, hello, hello. Hello, everybody, and welcome to the Tech Incubator HUBRAUM of Deutsche Telekom. Where? Super happy to see so many faces here that I know and so many new faces. Thanks very much, everybody, for coming. My name is Luis.
Hello, I'm Ender. I'm sitting here above in the Tech Incubator as well, so thank you very much for coming.
Thanks, everybody, for coming. Yeah, feel free to take places here. The area is huge. We also have another room for people that want to chill. At the end of the tunnel, the toilets for the women are on the left. The toilets for the men are on the right. There are little snacks here. We will have a break for the hungry people later with nice sushis. Yeah, baby. And now we're not gonna talk too much, I think. We are not the interesting people. We invited interesting people here to talk. The first one of them is Mario Bodemann from the Deutsche Telekom. It's an honor to have Mario Bodemann, Dev Relations Engineer from the Deutsche Telekom here.
Yes, maybe just I'll give you a brief overview about what you can expect today. So we start with tech talks. We will hear amazing speeches, amazing insights from really big people from the community and from the space. You will hear amazing facts, amazing opportunities. Then we go over to the break. We will have amazing sushi in the other room. There will be the catering. So you can eat while you build groups for the later hackathon. So we make small groups of 3 people, build together a product they pitch in 15 seconds. And then we will judge them, and the winner gets nice gifts. Also, in the end, there will be a DJ playing in the kitchen. So we do a relaxed beer, chill out, open end. But we try to finish around 7 or 8. Exactly. And everyone that want to go there afterwards somewhere, that is free to join any groups that go to the clubs. I think we are in Berlin, there will be some opportunities.
Exactly. Again, about the Ideathon, we have a QR code that's hanging outside here on the entrance and here on the screen for everybody that wants to register, be part of the Ideathon. The registrations are open until 6:30. You need to create teams of 3. Like Ender just said, we have awesome prizes. Really awesome prizes for the winning team. So it's just about creating an idea, building, getting to know the people around you, connecting. Yeah, I invite you to just ask questions to the people around you. It's a very open, moving community. Let's just connect and exchange and learn from each other. That's what we are here for.
Thank you very much for coming.
Thanks, everybody. And we leave the stage for Mario. Big round of applause for Mario Bodemann from the Deutsche Telekom, please. And thanks for coming.
Hey, so you know how it goes in a tech conference. I need to set up my tech. So thank you so much for this warm intro. And this is my slides. So welcome also from me. Also welcome to the Tech Incubator HUBRAUM. I had the fun task of building something with Web3, the blockchain, and I got to it and said hey, let's just dive into the deep end and find out how does the technology work and what can I learn from there. So speaking of technology, you are also sitting here in Deutsche Telekom, right? So I don't know if you looked around on your windows and onto the walls. We have quite some Wi-Fi here. We have some 5G actually indoor. And if you're part of our test lab, you can actually use it. And what you would do with it is you could change how you prioritize your phone's traffic over others in the same network. If you want to find out more, please find me afterwards and not only talk about Web3, but maybe also there's a combination of how do we do Web3 with classic APIs of a telecom infrastructure. For this one, I have vouchers, so if you want to get something for free, please tackle me one at a time afterwards. But now let's go over to why I'm actually also standing here, right? Like I said, I'm super summarizing Web3. I'm coming out of 33 years of development and programming and things, and for me, I'm taking the very deep down technology understanding point of view. So that's why I'm abstracting everything here happening also on Ethereum into just like, this is for me distributed RAM, right? Ethereum is for me a database where I just feel that like there are values inside that is distributed all over the place, and that there are some ways of like changing the values inside this RAM that are called transactions or function calls. And since I'm so much into technology, I also need a balance. So I thought like, hey, can I take Bella and Ziggy, my two favorite cats of two, and put them onto the blockchain? If you like blockchain, if you like cats, and if you like deep technical knowledge, deep technical insight into this one, please feel free to stay. If not, snacks are over there. Okay. So I already introduced you to Bella and Ziggy, and the question is, how do I actually get them onto the blockchain, right? I obviously need, because I'm an engineer by trade, I need to write code, so that is the approach I'm taking. Once I've written code, I need to deploy this somewhere. And since I'm an engineer, I also need money. So I don't have the money yet, but soon maybe. Okay, so let's find out more about the actual code part of my journey of getting Bella and Ziggy onto the blockchain. I found out through rigorous research that Solidity is the language to be used if I want to publish something on the Ethereum chain. If I'm taking a look at the source code, that looks kind of familiar, right? So like it's Java-like, it has semicolon at the end of the line, as we all like to still write our code. I'm sorry, I'm not trying to be too negative, but it's just, it feels familiar, right? I have an address, I have a string, I have a constructor, and I can save things with it. So what you're seeing here is a smart contract, right? So this is a thing I can execute on the blockchain. I called it Bella and Ziggy because I obviously want to call it Bella and Ziggy. And I want to put a message onto the chain that says Bella and Ziggy are amazing. And in this case, I actually say in line, 13, we love Bella and Ziggy, right? So this is in the end, once I have the contract on the blockchain, this will be somewhere on the big distributed RAM, and I have carved my name onto it. And since it is a public field inside this contract, I might even be able to change it. And with this teaser already, I also added a functionality on this code, on this contract, how I would change the message, right? If you're familiar with programming, this looks very familiar, right? So I am producing a new function that is called update message. This message gets actually only an integer because I don't want that like you can change whatever string there will be displayed. I want to have like only a fixed numbers of strings so that I can make sure that it like adheres to the general idea of the contract. If I would had any string in there, it wouldn't be about Bella and Ziggy, and that is the most important thing in my life. So like, yeah, I put in an integer in here as a parameter and then just check whether this integer is 0. If it is 0, then everybody loves Bella and Ziggy. And if it's something else, then obviously the question is, who are they? Coolio. So this is the code. This is the code I want to run distributed somewhere. And the question is like, okay, well, how does this now actually work in detail? How do I take this code and put it somewhere? My solution is that I'm first running the blockchain on my own machine, right? And for this one, I use a tool called Hardhat. With Hardhat, it's an implementation of the Ethereum chain that runs on my machine, and I don't have to pay for transactions. Once you installed it like the usual way, how you would install things on your machine, you can actually execute it on your command line. And I hope that you're not too worried about this one, but you will see more of command line during the rest of my talk, because I want to dive down as deep as I can and hopefully come back up. Once you have Hardhat installed it, you actually execute it, right? Once you run it in the project folder you designed for it, it asks you, hey, what do you want to do? Well, and for me, the easiest thing is like, I want to actually start a TypeScript project because I like typed languages or semi-typed languages. Let's discuss this later. Hardhat already offers me the opportunity to just start, not from zero, but like actually already have a sample project, which is amazing. I take the second option, and then it creates everything that it needs in order to execute my contracts on my local machine, and I can start iterating on it, what it actually wants to do. So if we are going through the command line, how to actually do the things I was just talking about in theory, you start a new node with Hardhat node and an npx in front of it, so that you actually run the chain locally and keep it running, so that you can like install your contract on the chain. But in order to install it first, you have to compile it, right? Compilation takes the Solidity source code and puts it into a binary that then can be executed on the chain. And once it's compiled, I can push it onto my local host, or I could push it somewhere else if I have the credentials. I don't right now. So that's why I took the local host. The interesting thing is the big long green string. Please, all of you remember this one. There will be questions afterwards. This is the address where my contract will be stored. This means I need this one to remember so that I can do things with this contract. And then for actually doing things with it, I need to find out what is inside the contract and how do I tell it Hardhat or Ethereum to actually execute it. This is done by creating a specific function reference, I want to call it. So every contract has several functions. It is the functions I have explicitly defined. I called it update message before and put the int there, but also implicit functions like the getter of public variables, right? So I have the field message defined inside my contract, and automatically Solidity creates for me a getter called field name and then brackets opening and closing, so that when I call it, I get the current value of the message. But in order to call it, I need to first take the string that is actually message bracket opening bracket closing, convert every character of this string into a hex value, then take this hex value and put it into my SHA-3 function. And since I don't know how to implement SHA-3 on the command line, luckily Hardhat has a functionality for this one already. So I have my local Hardhat node running. I can call with curl in this case, that is just executing a REST request on my local machine, the web3 SHA-3 function that actually takes the input string and converts it into the SHA-3 that I need later on. And once I've called this SHA-3, I get the response for the actual, I want to call it name of the function message of my contract. So also please remember the big yellow string down below there. It will be later on very important, and there will be questions. So okay, now I know where my contract is laying. I know how my message method, actually it's a function, is called, so I can now actually execute this one on the chain. How do I do this? Again, I wanted to go as low level as possible, so I used the JSON RPC in order to communicate directly with the chain and ignore all of the clown suits that are SDKs and stuff on top, because I actually want to understand how it works down below. And in this one, with JSON RPC, I need to call a function, a method called ETH_call. This one just calls a method without creating a transaction. What's the difference between a transaction and a function call is that a transaction changes the value on Ethereum, and a call just gets me the current value back without any changes. And if I want to call the message getter function, I need the to address of the contract, right? This is the green thing we were discussing before that Hardhat luckily provided me. And I need to provide the data that is actually the name or the address of the function that is the getter that lets us actually do things. Okay, so far, who's still with me? Hands up. Nice, I see hands up, that's amazing. For the rest, just come afterwards to me and I can do the same talk again. But luckily also, they're recorded, right? So if you want to see this slower or faster, please follow us on our YouTubes later on. But now that we have all of the details we need in order to see what message we were creating there once the contract was constructed, we execute it and we get this beautiful result as a JSON response. I was already hinting at that, that the result contains a lot of zeros and then some other things that are not zero. And luckily, that's exactly what I need, right? So I take a look into how I convert what the blockchain returned to me into something that I can actually display in the command line because I really, really need to see Bella and Ziggy again. I'm shading a bit what's happening here, but it is essentially the reverse of the function I was describing before, right? It walks through the result and converts all of the two characters into a hexadecimal representation that then can get converted into actual strings. It's not the most beautiful one, but it's the one that worked, and that's the criteria of my today's talk. So I do the magic over there, and in the end I can see that like actually on the blockchain on my local machine currently we have written "We love Bella and Ziggy." Okay, I see you are as amazed as I am. Thank you about this one. Let's just add up to the amazement here, right? Let's see, like, okay, we can actually see static values. That is amazing. Can we actually like change something? What is he talking about, transactions and things? So I just want to remind you of the other function we had in Solidity before, right? This is the update message function. So how do I now create a transaction that I can execute on the blockchain and actually change this, the text that is stored? It goes the similar way as we have created the name of the call function before, but this time we need to add a parameter to it, right? We want to give it a 0 or a 1 depending on which final value we want to see afterwards. So we start with taking the update message brackets uint value and convert it into hexadecimal. Once we've converted it into hexadecimal, we need to, again, convert it into SHA-3 so that we have the hash that we can then use to identify the update message function. But yikes, this is not this easy. There's yet another step involved because we don't just take the full SHA hash value, but we only take the first 4 bytes of the SHA and add the rest in order to have the parameter also represented in the function we want to call as a transaction. So we take the first 8 characters of the SHA we created, because this will be the first 4 bytes, and then pad it with 32 bits, 32 bytes of zeros that are then representing the parameter we are using. This is what I meant with ABI. There's a whole specification about like how do I formulate this string that looks like a hexadecimal value, but it's actually concatenated strings. I'm fine, this is fine. I just like, where I'm coming from is like, I was surprised that this is the way. Like, can't we just express it directly? Like, can't I just say, I want to call update message with uint 8? I'd love to understand if somebody knows more why we chose this as the way. But like I was saying, right? So this is the way how you create the hash for actually creating the transaction and the way how you would put in the parameters. If you want to know more how you not only put uints there, like numbers, but also strings or dynamics, there's a whole aspect there that I keep ignoring. Please feel free to click on the link afterwards and see how you would actually do those strings. Now we are at the time. We know what we do. We have the address, so to say, of the update function, and we have the parameter we want to put there. So we can start the transaction. Again, this is a curl call on my local node. The from is the first user that was created by Hardhat, so this way it's fine. The to is the address of the contract, and then the data is the whole thing I was just explaining. Once you execute it, I don't know if you can see it in the back, but the most important thing I found is that the result is not equals to null. If the result is null, or 0, this means there was something wrong with the transaction, like you had a wrong parameter used, or the function wasn't found, or similar things. If it's something else, then this means the transaction went through, you have a new block created, and the update on the distributed RAM you wanted to do actually happened. Okay, cool. So like now we know that the transaction was successful, but I want to actually see what is now happening with Bella and Ziggy. Well, the answer is the same as before. I can just execute the same call to the getter function for the message like I have done before. I don't need to change anything else because the address of the contract is gone and I still know the hash of the function that is the get message getter. Once I call it we get the other message, right? So like same call, different result. This means I have changed effectively the blockchain and therefore my contract actually works. And just for completeness sake, how would I make it show the other option of here? Well, I take again the transaction code I've done showed you before, but change the last character of the data string to be containing the 0 in this case and not the 1. So I execute this, I get something that is not equal to null. And if I execute it again to see what the getter returns, I get everybody loves Bella and Ziggy. And it is true, right? Everybody loves Bella and Ziggy. Okay, sorry for leaving some people outside. I will show cat pictures afterwards. Just find me if you need to see more. And like I just want to go also to like the non-optimal case, right? What happens if you are saying, hey, anybody, like somebody who is not the owner of the contract now wants to change what's displayed. Well, what would the chain return me in this case? The change is like I would create a transaction again, but change the from address to another user that is also happening to be on the chain. And the result is the one that we were expecting. We're getting an error message back saying you are not the owner, so you cannot change anything on the chain. Great. So this is my quick run through onto like how would I create a Solidity script that actually runs on my local blockchain. And with this one, I leave you to like actually take this script and put it onto the blockchain yourself in order to see if it would also work outside of Hardhat and like on the real world. That's your so-called homework. With this one, I'm just going to give it over back to the organizers and ask you for any questions, anything we would like to talk afterwards. Thank you. Please raise your arms if you want to speak so that we can give you a mic. Also, I'm totally fine if you're saying like, hey, Mario, what you just did is just not the way we are doing it. That's exactly what I want to hear. That's exactly why I'm here, because I, as you could tell or not, maybe I have only the clue of my own understanding how this works. I'm happy to hear from the community back. There's one question, please. so the question is, why would I use it with curl and not with the hardhead library? I wanted to understand what is the underlying technology, because I feel when you're using an SDK or the hardhead library, it's abstracting away from the things I want to understand. You know, where I was saying like, hey, why does it concatenate strings instead of like actually using this? This would have been an information I would probably not have gotten through the SDKs. I wanted to see like how does the hashing works and what are those things involved, just to get a feeling what's the underlying technology.
Yeah, I think very good demonstration of the underlying technology. I think for everyone joining just blockchain development, it's very important to understand that this is not the way that people would actually interact with a chain, right? Like,
Great.
This is very low level, and there are many, many convenience toolkits around this where you can just call update message with whatever message you want to send or you in. So yeah, but very, very good like understanding of the low level how it works internal of the.
Yeah. Thanks for the feedback.
Anyone, anything else? Any questions? I was seeing here a hand maybe or not?
Very low level, yes, I agree, yes. Great.
So thank you very much, Mario. That was like I was thinking I got an understanding, but now I think like I didn't get anything. So
I'm sorry, by the way.
I need, yes, I need to learn more about this. Thank you very much.
Thank you.
So thanks very much, Mario, for this very in-depth talk that also I learned a lot. And like Martin said, this is a very low level, so it's very from a programmer's point of view, an understanding on how to get into the blockchain. That's very interesting to see the different ways and approaches you can have to interact actually with the chain. And it's beautiful to see yours. Thanks very much for that, Mario. Without further ado, I want to introduce you Damien from Tezos. I'm not going to say anything more. Thanks very much for joining, and the floor is yours. Big round of applause for Damien, please, guys.
Thank you. So I also need to set up my computer. Give me a sec. So yeah, I'm not. 1 second. So how do I do this? So I guess you just see my bookmarks. Hi everyone. Thank you, Joe Baited and HUBRAUM and Peer Network for the opportunity to be here. I'm Damien Touzeau. I work as adoption manager at Nomadic Labs. Nomadic Labs is a subsidiary of the Tezos Foundation. one of the major actors actually developing Tezos ecosystem, in charge of developing and implementing the protocol, and also of driving the adoption of Tezos. So yeah, I work on the German market. So I'm here to talk about Etherlink. You might ask yourself, what is Etherlink? So, very short, Etherlink is a layer 2 blockchain that rolls up on Tezos. So, what is Tezos? Tezos was founded in 2017, and from the beginning, it was a public blockchain, proof-of-stake blockchain. It was actually one of the first proof-of-stake blockchain, among the big blockchains that are still there today. And from the beginning also included an on-chain governance system, which means actually when we want to push an update on Tezos, it's actually, and when I say we, it's the whole ecosystem, so the bakers, the validators, decide if they want or not to implement this update. Yeah, and that's important because, in our case today, because in 2023, we implemented the 13th update of Tezos, which is the Mumbai update. And the Mumbai update introduced the smart rollups. So, yeah, basically smart rollups are frameworks. A smart rollup is a framework to build your own rollup on Tezos. It can be an optimistic rollup, a ZK rollup, private rollup, an app chain, anything. So rollups on Tezos are enshrined in the blockchain, which means it's not another smart contract. They have their own address, their own type of address at the layer 1 level. So when you bridge tokens from a layer 1 on Tezos to the layer 2, the tokens are not held in a smart contract and then replicated on the layer 2, but they are actually literally transferred from the layer 1 to the layer 2. So one of the interests of this is that actually allows you to avoid smart contract risk, and you don't rely on a centralized entity like an Oracle or any other entity to bring you. So to wrap it up, smart rollups are a trustless bridge between the layer 2 and Tezos, and it's fully handled by the protocol. So after the implementation of Mumbai, we had a demand from the ecosystem, especially corporates we work with. The Tezos actually works a lot with corporates. So corporates like Ubisoft, Decathlon, Société Générale, Deloitte, and this demand was to become EVM compatible. So that's how we started working on Etherlink. And what Etherlink really is, it's the demonstration of an EVM compatible smart rollup on Tezos. The main feature we want to achieve are so low fees. It should be around 1 cent, $1 US cent for a swap, for example. So that's actually the goal we have, so that we can provide a good environment for DeFi applications. It should be permissionless. It's actually an optimistic, permissionless optimistic rollup, and we chose optimistic rollups because it's kind of the tech that is the most mature right now for rollups. But it doesn't mean that we won't implement some zero knowledge features in the future. One other feature we want to have is a competitive latency. So below 1 second or 1 second or below for transactions, and MEV protection in the protocol. So to achieve these two, competitive latency and MEV protection, we are using a decentralized sequencer. So actually most of the layer 2 blockchain now use, the optimistic rollups at least, use sequencer, and we want it to be decentralized. And why we need a sequencer is because on Tezos, the block time is 15 seconds. So you cannot have, but while relaying on the layer 1, a transaction latency below 1 second. So what happens actually that this decentralized sequencer compute the states of the rollup and then send the blocks directly to the rollup, so the smart contract. It's not a smart contract, it's a rollup, but on the layer 1. So yeah, the decentralized sequencer achieve the consensus at the layer 2 level. And so I don't have actually right now all the technical specificities of how we protect you against MEV. So MEV is actually maximum extractable value. It means that a node is able, by ordering the transaction, to add his own transaction and get more value out of it, because he knows at the moment he pushes the block, he knows what transaction will happen right after or right before. And with a fair transaction ordering, we should be able to protect you against MEV. But this is not yet fully disclosed, how we do it. So, in the idea, the rollup is still the validator of the blocks, but is not in control of the ordering of transactions. Additionally, Etherlink will inherit the governance model from Tezos layer 1, which means the bakers will decide of the future of Etherlink. The bakers are the validators on Tezos, the nodes. So, for example, so in a decentralized sequencer, you have a sequencer committee. So many entities running each their own sequencer and taking turns in creating the block, for example. And if the community of the bakers of the layer 1 is not happy, or if the sequencer committee is not behaving correctly, the bakers can decide to change it. So, what to expect at launch of Etherlink? So first, Etherlink is set to be launched in March. Actually, the version that will be launched in March is some kind of beta mainnet. So there won't be every features ready, and every feature that I presented there, especially the decentralized sequencer, will be ready in June, just so you know. So what to expect? We will have bridges from every EVM environment using layer 0 because we partnered with them. And what is good to know is that we will be subsidizing the transaction cost. So you can, for free, from any EVM environment where you might have today tokens, you can, for free, bridge them to Etherlink. You will be able, actually it's not ready. You will be able to bridge them to Etherlink for free, try Etherlink, do whatever you want, and then bridge them back for free also to the layer you came from. But ideally, you stay on Etherlink. So we will have also a state-of-the-art Explorer with Block Scout. So like very good Explorer. And you will be able to use oracles. So for example, we partnered with Redstone to offer price feed for free to any DApp user, a DApp developer. So if you're interested in starting a DeFi application on Etherlink, you can have the price feed for free. We'll have quests with layer 3 to push for the adoption of Etherlink and try to get people to use Etherlink and discover the functionalities, etc. And of course, as we are an EVM, as it will be an EVM compatible blockchain, you will be able to have access to all the EVM tooling that already exists, the libraries, the indexer. We partnered with the Graph to be fully integrated on their decentralized network, both on mainnet and on testnet. And every EVM, not every, but many EVM wallets like MetaMask, Hubi, or you name it. Okay, so in a nutshell, EtherLink is an EVM compatible layer 2, expected to launch in March. It will actually won't be it doesn't, so the goal of EtherLink is not to be like the only smart rollup or the only rollup on Tezos. It's just an example of how we can build EVM compatible rollup on Tezos. Anyone can still start his own rollup, and actually we aim to deliver an SDK to allow everyone to start its own EVM compatible rollup or other kind of rollup in the future. Another notable improvement that will be coming later on EtherLink will be the Tezos data availability layer. So it's actually already working on test, and it should be available for use for any rollups on Tezos, or actually can be replicated, starting H2 2024. So, how can you be part of EtherLink if you want to? So, EtherLink comes with its own builders program. The Tezos Foundation, actually we have a budget, quite a high budget for EtherLink, and we created a builders program where you can get marketing support, strategic growth support, technical support, and grants allocation. So the technical support will consist of smart contract review, trainings, or anything. If you're actually starting to build with us, you can count on all the teams at Nomadic Labs and 3D Tech to help you start your decentralized application. The grant allocation will be up to 200,000 USD for application that, in our opinion, or in the opinion of the Tezos Foundation, are worth it and that are needed for the ecosystem. So don't hesitate to start to launch your project on EtherLink and join us. So yeah, so feel free to join the community also on GitHub, Discord, or Twitter, or X, and feel free to reach out to me. Added my socials below, and yeah, if there are any questions, I'm ready. Yeah, of course. So the difference here is that we are not like, we are EVM compatible, but not Ethereum layer 2. It's a Tezos layer 2. Yeah. Yeah, but so. Yeah, of course, of course. That's why actually we don't, we keep on pushing also Tezos Layer 1 and developing Tezos smart contract languages. So it's Mikkelson, and it's absolutely not, we're absolutely not making EtherLink like the Layer 1 and Tezos like just the layer where you anchor stuff. But it's, let's say, we have partners that work with us on Tezos, but also work with other EVM chains. So we want to be able for them to stay on the Tezos ecosystem while using the application that are actually built for EVM. Also, today, let's say 95% of the smart contract developers develop in Solidity. And so if we want them to be able to start on Tezos without going through learning a new language and maybe just kickstart, just put them show them Tezos ecosystem, how it works and how we develop it. And because it's also the idea is to be truly decentralized compared to some other layer 2s with a decentralized sequencer and the foundation having only a very limited decision power in the evolution. Yeah, the idea is it's for it to be an entry to Tezos layer 1, kind of. And to be an efficient chain, especially for DeFi, actually. All right, thank you. So.
Thanks very much. Big round of applause for Damien from Tezos. And the beauty of this event here is we are all here, the speakers as well. Mario is sitting here. Damien just went off the stage. If you have any questions, Damien also left his personal contacting. The beauty of this event is that we can talk to each other and we can even talk to the speakers directly. If you have any questions, feel free to talk with them. Now we're gonna go off to a 5 to 10 minutes break so our brains can reset. Everybody just take some snacks, some Club Mate, so you have some more energy for the next tech talks. My brain is already burning a little bit. We'll be burning even more afterwards. Right, Ender?
Definitely, yes. Also, we will have one more additional tech talk from Hive. So there was a little bit of misconception in the planning. So please think about like 15 minutes more for one more tech talk. Thank you very much.
And don't forget to register, scan the QR code, register for the Ideathon later if you want to win the awesome prizes. We have a proper package, nostalgia package we call it. We're not going to say what the prizes are, I think. You're just going to have to wait.
But you can try them out in the kitchen. So, if you
all right, yeah, take some snacks, grab some snacks. We'll be back in 10 minutes. Let's fucking go. Whoa, whoa, whoa.
Oh yeah, because of the music, the DJs are building up in the kitchen the live sets, so we will have live music with later on. But right now we will like chill. It's not even 4 p.m. We will start later with the music. Thanks.
Hello, hello. Hello, everybody. We're gonna start in 2 minutes with our next talk. Chris Nagy from Solana, Super Team Germany represented here. So, if you want slowly to get back to your places and get some of Chris' brain juice, feel free to take a seat.
Get the brain juice, baby. Oh wait, there is an actual output?
Yeah, definitely.
I guess this is it. Nope. Nope, it's not in there.
Why can't you set it to
Here,
HDMI?
press run. No, I set it to HDMI. It is. It's just not giving out any. It's okay. Don't worry. Don't worry.
Don't worry. We will put on music later.
Okay. That's all right. I think everybody's good, yeah? Do you have a laser pointer?
No, I did not find one. Sorry.
I guess I'll just use my finger then.
No. You do it.
Okay. I'll just get started, all right? Yeah. Can I? Test 1, 2. Oh, beautiful. This is really cool. Okay. How's everybody going? Yeah, how's everybody doing? It is a good day out here in Berlin. Happy to be here. Excited for this event. It has been a while since I've done a talk on Solana. A couple months actually. So forgive me if I slip up and join me in discovering Solana. So who am I? Director of Vibes. My official title is Director of Vibes at Super Team Germany. Super Team Germany is essentially the Solana presence here in Germany. We run a community here, a Solana community. We have been doing that since 2020, end of 2021. We have grown to about 150 members. We do events. We support builders. Our core focus is essentially getting developers into the ecosystem, getting people into the ecosystem, and helping them achieve what they want to achieve, whether that's being a founder, whether that's finding jobs, whether that's earning. We help with everything as a community. We actually have quite a few members here also, but yeah. So what I'm going to do is essentially just a higher level overview of Solana. Actually, I want to get a show of hands. How many of you have used Solana so far? Oh, my heart has already melted. Okay, so that's good. That's actually quite bullish. So a lot of you already know what it's like on Solana. And for those that don't, then this is the first time showing. So a little bit of stats just to get an anchor of what Solana is doing nowadays. Our current transactions per second. I just did this presentation like 2 hours ago, and this was a screenshot of live. Current true TPS is 700 TPS, right around 700 and 900 user submitted transactions processed a second, and total TPS is about 4,000. The difference between true TPS and total TPS on Solana, which has caused a lot of FUD in the past and still does, is essentially, think about total TPS, that consensus on Solana is done through transactions. Solana is so fast that you can do consensus through transactions. So votes are essentially, votes are part of the total TPS. So total TPS minus true TPS is just voting transactions, where validators vote with each other of like, yes, this process a transaction, yes, I vote, this is good. And so that vote is also a transaction. So you can think about total TPS as Solana is essentially running consensus through itself through transactions. But the main important part is true TPS, which is 730. It is actually right now on Solana FM. We were just at 900. What is it? 920. So quite a lot of transactions. We have scaled in transactions quite fast since last November. But yeah, it's just humming along. So a little bit of a network overview in terms of numbers here. We have had, just to give you a scale, because a lot of people don't know how many people actually use Solana. It has been such an underdog chain, and it has such in the background that nobody really thinks that it's like active or there's anything going on, because people just don't know, and that's fine. And so essentially, we have average daily fee payers of 190,000 wallets. This is essentially 190,000 average users a day of the chain, and average daily signers of 400,000. I'm gonna be honest, I actually don't know what the difference between these two is, but I'm gonna ask Ryan next time I see him. Yeah, so average daily non-vote transactions is 40 million. So 40 million average user submitted transactions a day in Q4 2023, which is quite a lot, if I may say. Here's an ecosystem map. This is just a very high-level ecosystem map of all these are like the biggest companies and biggest things. Help? Did I do something or? Der sagt betriebsbereit. It's back. We're so back. We are so back. Okay. So quickly, because I think I'm running out of time already. So yeah, we have a bunch of DEXs. We have a big DeFi. We have a big DeFi sector in Solana that I'm going to dive straight in. But yeah, we have liquid staking. We have a lot of liquid staking protocols. We have a large amount of stable coins as well, namely USDC. So most of USDC supply is actually on Solana. And we have DEXs, aggregators, a lot of shitcoins recently, which is good for economic activity. We have here two main meme coins, which is Bonk and Whiff, whoever has seen Dog Whiff Hat recently. And then we have a lot of NFT projects, a lot of gaming projects as well, yada, yada, yada. We do payments as well. I wish there was here, but it's okay. We're making it work. This is not the first time that something went down, so. Yeah. Yes, it's okay, it's okay. Okay. There we go. No? Maybe? That was so good. It like kind of held the room for like 2 minutes. Let me just unplug and plug it in. Do you have an adapter maybe or something? Back? Are we back? We are not back. Okay, we're not back. Well, we're back. Okay. Do not touch. Do not touch. Okay. Now move it. Yeah, dev tooling, bridges, wallets. We have 4 validator clients with the 5th one in the work. Solana is the second network that has multiple validator clients, which is huge, incredibly important, so that things like this outage doesn't happen. Okay, let's actually hop into DeFi. The original vision of Solana, Anatoly's original vision of Solana was let's put NASDAQ on chain. And basically, if you can do that, you can do everything else. If you can put a economic activity like the NASDAQ on chain, every single transaction, all the trades, if there's a blockchain that can execute that, you can do everything else. So that's essentially the underlying vision, and hence Solana is a very active DeFi chain. It has not been the case through 2023. We had a lot less activity because things happen. But now it has heavily come back because the chain is a lot more stable as well. So just in terms of like, okay, what is actually happening on Solana? What are the actual transactions on Solana? These are screenshots from a Dune dashboard about Solana activity. So top programs by compute units. So essentially who's using most of the block space, who's using most of the compute. Number 1 is Jupiter. I'll show Jupiter in 1 second. Jupiter is essentially, if you know Uniswap, it's just Uniswap, but like this, instead of a lot of back and forth. Whirlpool, that is the Orca Whirlpool, so that's an AMM, again, also a DeFi protocol. Radium, also DeFi, CLM. SPL token is essentially is the program that handles all of the tokens on Solana. That includes fungible and non-fungible tokens. I'll outline a little bit of how this is different on Ethereum or EVM land. You have a contract per token or per NFT. There's their NFT collection, there's a separate contract. On Solana, all of the tokens are handled by this one native program called SPL token. Jupiter v4, and then this 6Q4, I actually don't know what that program is. Drift is a perpetuals protocol, so also trading and Radium. So as you can see, most of the compute on Solana in every block is actually used up by DeFi protocols, which is very bullish. So yeah, also here in the average, these are basically, all of them are DeFi. All of them are DeFi. Bubblegum is actually compressed NFTs, so that comes in quite a lot here. But everything else is DeFi. But this is not Amount of transaction, this is compute units, since DeFi is much more compute heavy than, for example, an NFT trade, right? So this is Jupiter. Have you seen Jupiter before? Who has seen Jupiter? Very good, very happy. For those that have not, let me show you what Jupiter is like. So you have seen a regular swap interface. I'm gonna come here, put in, let me swap 1 cent into WIF. I swap 1 cent into WIF, so I just click swap, bada bim, comes up this much. The demo gods are not with me, hopefully they are. Slippage reach, because I haven't refreshed. So, one more time. So I'm gonna swap 1 cent into WIF, swap. The demo gods are really not with me. Please. There we go. There we go, that worked. So that's a swap. I just swapped 1 cent. I can do it again. Want to do it again? Let's do it again. Let's do it again. I swap 1 USDC. Want to do it again? Let's do it again. Beautiful, yeah? The point I'm trying to make is that these are actually fully on-chain transactions. I just swapped 1 cent into something else, anything else, right? With essentially this tiny of a spread, this 0 fees within 2 seconds. This is the experience. This is the top premier way of showing what Solana is capable of, because the small fees and the speed and look here, 1 cent. This 1 cent is getting actually split into 2 hops. This is what's happening with my 1 cent. This 1 cent is getting converted to USDT on Meteora. Then that USDT gets converted to Sol on Radium, and then I get my Sol. For 1 cent, these are the computation that Solana is able to do at 900 transactions a second. So 900 of these every single second are going through the chain that is hopping multiple hops for 1 cent. This is the freedom of economic activity that Solana allows. Okay, I have here Jupiterage if you want to try it out, all of the points. So the other one is Orca. So Jupiter is essentially just an aggregator. It's like 1 inch. It's not like Uniswap. They don't run their own. Pools. Meteora is one of their daughter companies, and they run pools. But they're essentially relying on all the other liquidity pools in the Solana ecosystem and aggregating them, and then hopping and swapping and finding the best route across all of DeFi for your 1 cent transaction or for a 1 cent swap, right? So we have Orca. Just to show a little bit of numbers, I don't know if you can see these numbers in terms of liquidity size. The Sol USDC pool just on Orca is 4.6 million liquidity. USDT USDC 6.7 million liquidity. So there's quite a deep liquidity in the ecosystem now, luckily, because the fact of the matter is actually Solana has low TVL compared to for example, if you take Ethereum's TVL, I don't know what it is right now. What's Ethereum's TVL right now? Does somebody know? Anyhow, billions, 20, 30 billion, right? Solana can do with 1.5 billion TVL, double, triple the actual daily volume because of this speed and because of this velocity. Radium is another one that is also so Orca and Radium are essentially the most used liquidity pools. All of the shitcoining recently and until now also happened on Radium. So if you see here all of these the active liquidity pools, all of these are pretty much shitcoins. Shitcoin is in a good way though, because it's part of the culture of crypto. So GME with Bonk is not a shitcoin, it's a meme coin. Whales, yeah. So these Myro, these are so fresh that they don't even have the names yet. So yeah, Radium and Orca are basically the basis of Solana liquidity pools. Another incredible thing that you're able to do on Solana that you're not really able to do in any other ecosystem that I've seen at the scale, in new chains, yes, but central limit order books is essentially, so Serum came out first. This is something that was built by FTX originally in the early days of Solana as a proof of can we do this on Solana. Central limit order books are essentially the same way that TradFi works, is that, hey, I have here $100, I put in, I want to sell, or I have here 1 Apple share, I put into the book, hey, I have 1 Apple share that I want to sell for $100. This is an offer, right? And then somebody else on the other side comes in and hey, I want to buy an Apple share for $100. And so the order book essentially matches me with that. But each of these puts, each of these offers is a full transaction, like in TradFi. You submit hey, here I have an offer, put it in, and it's in the book, right? It is literally an order book. So this is something that is really, really hard to do in a in traditional chains, like for example in Ethereum, traditional chains, because every single transaction would cost you quite a lot of money, right? Whereas with Solana, if your transaction costs 0.000005 Sol, a transaction cost, this is pretty doable, right? So this was one of the key inventions, key realizations of like, you can actually put a full central limit order book on Solana. And there's multiple ones right now. There's OpenBook, Serum is somehow still alive. Serum was by FTX. And there's also Drift. So Drift also does central limit order books. But yeah, if you can do a central limit order book on a chain, you can do quite a lot of things. Okay, let's go into NFTs a little bit. How am I doing on time? Perfect. Let's go into NFTs a little bit, because also quite a big topic on Solana. Just in terms of volume, been doing pretty good. I think right after Bitcoin, I did not know that Bitcoin had such huge NFT scene. I mean, I knew about ordinals, but my God. Yeah, so it's essentially the same size as the ordinals market, the Solana market, and then Ethereum is just, a lot higher. But yeah, so in terms of numbers, this is, I don't know how up to date it is. It might be like a month or two old. But there are 14 million wallets that ever held an NFT on Solana. The cost of minting an NFT with state compression, that I'll explain a little bit, is that much, like 0.00011 cents. And then there have been 110 million total NFTs minted. I know this is a lot more. I think it's more like 140 million now, because just Drip alone minted 100 million NFTs. So what is the NFT ecosystem like? What is it like to buy NFTs, sell NFTs? One of the biggest the biggest NFT marketplace on Solana is Tensor. I think Tensor is going to be the largest NFT marketplace in 2024. I'm pretty certain of it, actually, because this is the experience that you can have, right? So this is Tensor, just showing you real quick of what it's like. The Wi-Fi is rugging. Please don't rug. The demo gods are really not with me today. Okay. Well, I just wanted to show you what it's like buying an NFT here, but it apparently is not going to work. Let me try my phone real quick. Give me 1 second. I think it's really, really important, really, really cool. So I really want to show you. Here, okay, there we go. So these are compressed NFTs. So Drip is one of the I'll tell you a little bit about Drip, but this is essentially the process of here's an NFT. I want to buy this NFT, preparing, yada, yada, yada. Confirm the transaction. So I'm going to buy this for 0.00. I don't know how much that is. Probably like 10 cents. And boom. This is it. Order complete. That's it. I have the NFT. If I want to sell that NFT, sell now. Here, sell. I'm just going to sell into the pool. I actually don't want to sell that. But if I would click, this would be the same experience. I just don't want to sell this NFT right now. But this here, compared to other ecosystems where you can buy NFTs, like if you compare this to the experience on OpenSea, wildly different. There's no approvals. There's no. Okay, you need to approve this. Okay, you need to add this. You just click approve, and 3 seconds later, you bought the NFT, and that's it, for essentially a fraction of a penny. Yeah, so this is why I think Tensor is going to be the largest marketplace, is because it's just an incredible user experience. The other one is Drip House. Who has heard of Drip House? Somebody has heard of Drip House? Very good. Okay, all my Solana friends have heard of it. So Drip House is actually the fastest growing consumer app in all of crypto. Drip House has 100,000 daily active users. What they do is they essentially give you free NFTs. You can subscribe to creators. That you can do here is, let me just go to here, drip.house. You can subscribe to these channels. So each creator has one of their channels, basically. And what they do is they just airdrop you. They just airdrop you art. They just airdrop you collectibles. They just airdrop you things here, right? So for example, here, this Alkebulan, I'm going to subscribe to their channel. And this is their new channel here. Like Amit, yeah, this is a cool creator. I really like this creator. And you can essentially just subscribe to this creator. And what they do is every week they airdrop you their work as a collectible. This flips on its head of what collecting means of like, hey, I need to pay money. No, it's just you just get the free NFTs. To put this to scale, Drip. So like they have collectibles and everything. To put this to scale, Drip mints on average in Q4 2023 400,000 NFTs every day. Only Drip minted 400,000 NFTs every single day on Solana, and they have minted over 100 million NFTs throughout their lifetime, which is just incredible numbers. And it costs them basically $150 to mint all of these NFTs. Like every day, they basically pay $100 to mint 400,000 NFTs, thanks to state compression. So this is about NFTs. There's a lot more, but I want to be aware of time and go into community, because this is the thing that really kept Solana alive, because people are just like, I'm not leaving. I'm not leaving. I love this. I think this is the future of where this is headed. The tech is just so good, and Anatoly is such a Chad that we're not leaving. So one of the big things that Solana did that really evangelized me personally is hacker houses. They've essentially done, imagine a 4-day event, just like in a really cool big venue, like here, for example. This was the Berlin Hacker House just a couple months ago. You get a big venue, they get 400 or 500 of these Solana Chads in for 4 days. You get workstations, and you get free food, and you get music, and then you get all of this. Basically, you just get the whole ecosystem together in every part of the world. So last year, there were like 10 hacker houses that you get in London, you got Berlin, you got Singapore, you got Abu Dhabi, you got a bunch of these places, right? So these hacker houses were incredible idea, because like twice a month, essentially, somewhere in the world, they just brought together 200-300 Solana people. There's 200-300 Solana developers, heavy focus on developers always. So this was a group picture from Berlin Hacker House. When was Berlin Hacker House? September, yeah, last September. So yeah, and everybody gets to know each other. Incredible for the community. Another big one is hackathons. Solana hackathons have been, there have been this many hackathons. So these Wormhole and DeFi hackathon was like the original. Solana season was the first proper hackathon. Ignition, Riptide, Summer Camp, Grizzlython, and Hyperdrive. So these have been the hackathons in the past 3 years. And as you can see there, each of them have more project submissions than the ones before. We hosted in Berlin the Summer Camp, the Grizzlython hackathon, and then latest was the Hyperdrive hackathon. And the platform that is now going to be, there's a new hackathon coming March 4th. It has been announced. And if you are interested in that hackathon, the platform is coliseum.org. So there is this platform where they are starting, essentially, they're moving all the hackathons for Solana hackathons into this new platform called Coliseum. Do check that out. There is a hackathon coming. Another point is build stations. This is something that we have done. We have started here in Berlin. This March was the first one. So what this is essentially, we have rented a space for about 4 weeks, just like a hacker house. Imagine a hacker house, but for 4 weeks. We have rented the space for 4 weeks here in Berlin at the W3 Hub. And we just had workstations and workshops, and then the demo day at the end for the hackathon. So these are the things this is the ground up level, this is the ground up integration of the Solana community and the Solana ecosystem, is that there's a global hackathon, and then all around the world, there were a couple build stations in Berlin, there was one in London, there's one in India, and people are able to come and just build for the hackathon together. It's a global online hackathon, but still you have these in real life places, and this is a huge upside where people just come in and get to know each other and get the help they need. Imagine you're building for a hackathon for 2 weeks, 3 weeks, and you get stuck on something. And instead of spending the whole day trying to get unstuck, you just look to your right, ask your buddy, hey, have you seen this error before? And he's like, oh yeah, it's a weird fucking error. You gotta like change this in your configuration and then it's gonna work. Oh shit, thank you. This is the power of in real life, and this is the power that these ecosystem things can, that these in real life things can bring. We are hosting also a build station from March 19th to April 9th. There is the next upcoming hackathon for Solana. We are hosting a build station here in Berlin again for the next Solana hackathon that is from March 4th to April 8th. Here is a QR code. If you want to scan it, I'm going to give you 3 seconds. There we go. There's prizes, there's more, but we'll get there, we'll get there. I'm just checking on time. There we go. You good? Okay. Yeah. So this is the community part of what has made people not want to leave the ecosystem. Now for a little bit of a technical deep dive, I wanted to give a higher level overview and just touch on some technical topics because I'll just refer you to some people that are much better at explaining all of these things than I am. So number one is there's a GitHub repo called Solana Workshops. If you are interested in essentially what I'm going to say just now, like in a deeper way, there's a whole repo full of workshops, full of recordings, and full of presentations of just everything explaining the Solana account programming model, right? One huge thing that Solana has been able to do that really separates it out, that allows it to have these tiny fraction of a cent transaction fees, is parallel processing. So EVM so far, except for the new chains of Monad and whatnot, EVM has been single-threaded, right? Not single-threaded, but how do you say it? Basically, single transaction processing. I submit a transaction, he submits a transaction, mine is going to go, and then his is going to go, right? The difference in Solana is Solana processes transactions in parallel. This is why it's so fast, is because it's able to process my transaction and your transaction and your transaction and your transaction at the exact same time. Now, what this does is, hold on. Yeah, so there's an issue with this, is that if I have a high usage, for example, an NFT mint is happening over here. Yeah, an NFT mint is happening over here, and then you're trying to submit your Solong over here on your DEX, and then you're trying to swap something else here, and then you're trying to buy this NFT here. Then all of those are going to congest the state in the same way. So what they came up with is essentially localized fee markets. What localized fee markets mean is that fees are per program now. So if the Jupiter program, for example, is having 100 transactions a second, because everybody's now trying to swap, then the fees for the users that are using the Jupiter program are going to increase by a tiny fraction. They're going to increase, but it's not going to affect me minting my NFT over here. Or the other way is that if there is an NFT mint happening here that 10,000 people are trying to mint in 1 second, because you know how it goes, people are just like, DJs are just like, I want to buy this. And then there's a million bots. Like there's a million bots submitting literally a million requests a second. This is not unheard of for NFT mints. There's a million requests a second on this NFT mint. Then my Jupiter swap should not be affected at all. And this is what localized fee markets do, is that they raise the fee. It automatically raises the fee on that NFT mint. Anybody that is interacting with that raises the fee. But the fees are the same here. And what that really does economically is that it limits how many transactions are going to be submitted here, because botters are, for example, disincentivized of submitting 1 million transactions per second because their fees are going to be raised and it's not economically viable anymore, right? And so that's why over here, my Jupiter swap is going to be unaffected by a very hyped NFT mint. And this has really brought the ability for Solana to execute all of these things in parallel. For example, when it was very funny. When Mad Lads minted, this is like the top collection now on Solana. The same time that Mad Lads minted, and it was like sold out within 3 seconds, everybody was just like smashing it, right? The same time, Helium was minting 1 million compressed NFTs to represent all of when they migrated over to Solana. At the exact same time, there was a hyped NFT mint with millions of transactions a second, and Helium was minting 1 million, like hundreds of thousands of NFTs every second to their users at the exact same time. And the funniest thing is they didn't even know about each other. The Helium guys were just like, oh shit, this is also happening? Oh cool, we didn't really notice it. So localized fee markets really made that possible. And just be aware of time. Programs, just a hint, just a touch on programs here. Solana, smart contracts on Solana are called programs. You can also call it smart contracts, but they're just called programs. The big difference here in comparison to EVM is that programs are stateless. In Solana, like the executable code, the executable is stateless, and we use something that is called PDAs, program derived addresses. It's something that can be imagined as there's your program with your executable code, and all of the data is stored in separate accounts. So on Solana, everything is a separate account. Everything is an account on Solana. So your executable program is an account, and every single data point, for example, that I have, I create an account for myself on this DeFi protocol, and that essentially creates a sub account on this program that is just tied to my name. But there's more that you can explore here in the workshops, right? One other thing here is that the reason, so there's parallel transaction processing, right? But since everything is an account, how do you know, how can you avoid writing to the same account at the same time, right? This is a big issue. How do you avoid writing to the same account at the same time? If I submit the transaction, you submit the same transaction, how do you parallelize, right? And the way it does is that for every single transaction that you submit, you need to pass in all of the accounts up front. All of the accounts that you're going to read from and write from, you need to pass it in up front so that the runtime can figure out of, okay, this account is going to be changed here, this account is going to be changed here, okay, so I can execute these in parallel, I need to put them after each other. But this and this transaction I can execute in parallel because they're touching completely separate accounts, so I can execute them in parallel. And this is a big thing of, this is just a big difference in Solana, the programming model, that you need to pass in every single account that you're going to touch with that transaction up front. And you need to pass in, is it going to be changed, is it mutable, and is it a signer, right? So you just basically just send a program ID, hey, to this program, these are my accounts, and this is the data that I want you to execute, right? Okay, so some amount of time, I'm just going to pass through this. We are Super Team Germany. This is the best way to contact us. This is the best way to, not contact us, to keep up to date with us, is to just go to our Twitter. There's a link tree here. Everything is behind the link tree. If you want to learn more about the build station that's happening and what we do and yada, 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 this is the best way to do that. And that's about it. I might go back after that if you want the workshops link. I can show you that after. But that's about it. Do we have any questions? Can we take some questions? Yeah, right? A couple minutes. Do we have some questions? Hope to answer them. Everybody's shy to put their hands up first. Yes. How you doing? Yeah. So, yeah, this is something that I myself actually wondered as well. One important thing here is here. So let me find just this this dashboard here. So there is a limit. The limit comes from compute units, right? So every single transaction essentially has a certain amount of compute that it takes, right? And you pre-specify that as well. Here's the chart essentially. There is a limit. Right now, I don't know how they're going about it. This is essentially average amount of compute units per block, right? So we're actually quite high. We are quite high in that. I don't know what the theoretical limit is. It also depends on what kind of transactions are there in a block, right? If you're hitting 900 heavily computational trades, then it's going to take more compute than just 900 NFT purchases, you know. So there is some form of a limit. I don't know how they're going to go about it. Actually, I'm pretty sure that they know that this is something and they're working on it heavily, either by scaling hardware or just simply like what FireDancer is going to do to this. I don't know. But this is essentially the current state of compute unit per block. We're pretty much like, I don't know, I think that's at 50 million. So we're at like, what, 80% currently, quite stable. I don't know. We have hit 1,300 transactions per second with like non-vote transactions, and that worked. I don't think it ever like hit the limit, but yeah, I don't know. And if you have a lot of user transactions, then the vote transactions actually go down because it just uses a smaller quorum of validators to vote. So yeah. I don't know. We've hit 1,300 transactions so far. That was the highest that I've seen. Yeah. Yeah. at the end of the day, yeah, it's compute units that is the ultimate saying of like, okay, how many transactions can be in a block, total compute units consumed. Yeah, but that also scales with hardware. So this is the big bet that Anatoly is betting on, which is right. It's just hardware is going to scale, right? So you can increase compute units with hardware, and I don't know what FireDancer is going to do to this, which is like the super high frequency trading validator client that's coming out of Jump. I don't know. It's just compute units at the end of the day. Second question? Yeah. Yeah. Yeah, yeah. Yeah. Look, latitude.sh. So you can run, I actually ran a Solana validator one Saturday. I woke up and I'm like, I'm going to run a validator. And I did. In about like 4 hours, it just spun up, right? This is essentially the, where is that metal? There we go. Where is the pricing? Here. Hopefully it shows my types of, just looking for essentially the, here, machine types. Which one is it? C3 large, yeah, I think it was this, $408 a month, yeah. This is essentially a recommended box for running a validator on Solana that can actually like keep up with the network. Is C3 large x86, 24 cores with 200 gigs of RAM. Actually now it's only using like 20 to 40 gigs of RAM, the validator client, because they basically like in 1.17 they got rid of a lot of tech debt. So it went from 130 gigabytes to 40 gigabytes of RAM used. But this is essentially the box that you need. You need about 2 terabytes of NVMe. You need a bunch of RAM and a 1 to 10 gigabit per sec connection. This is not a Raspberry Pi, very much so. But on the other hand, yeah, this is the thing. This is how Solana runs. It just runs on high performance computers. But luckily, hardware gets cheaper every time. Like hardware is just getting cheaper and faster. So yeah, it's just a different approach. It's a different approach than for example, what Ethereum takes. And it's a different also just way of looking at it of yeah, except for instead of being able to have like 10,000 separate nodes, you have 2,000 or we have 2,000 validators right now live on the network. So I don't think it's as prohibitive as many people would like to say and made you believe, because we do have 2,000. Yeah. Yes, third question. Yeah. So the Solana validator codebase is just one monolithic application. It's all in one. So if I run this validator, I click Solana validator start, put in all the flags, and I hit enter from 0, it will literally download all of the state from other validators, it will catch up with the network, and it will start validating. It's just one monolithic thing, and everybody has the same. Yeah. Yes. You need no stake. Well, you need basically 1 sol a day it costs to vote. All the vote transaction costs 1 sol a day, but you don't have a minimum stake requirement. The thing with the stake is that you do need this 1 sol per day. Basically, that it is going to cost you 1 sol per day to vote, to be an active voter in the network, and to be able to make 1 sol a day, you essentially need about 50,000 sols staked to your validator to make 1 sol a day. So basically, to break even. Is that much. But it's actually very interesting. A lot of nodes, a lot of validators on Solana, like there's a lot of validators that do this as a business, right? Of like, okay, this is our business validator, stake with us so that we have more revenue, yada, yada, yada. But a lot of them are actually like, for example, think about Circle, right? The reason why Circle runs a validator is that they have a direct connection to the network, right? They're not going to ask RPCs. They're not going to ask anybody else of like, hey, has this transactions went through? Because it's like, oh, they're running their own nodes so that they have a direct access to the network and they have trusted information that, okay, this guy actually did this transaction, we can mint them $1. So a lot of nodes are actually on Solana are not running for making profit. It's running to have the direct access to the network, like Circle, like a lot of others, payment providers. Yeah, but you essentially need 50,000 is like the break even mark at running a validator. But you don't need a minimum stake, and you can stake any amount. Like you can stake 0.001. Like I can stake at your validator any amount. Yeah. One last question. Anybody? Going for once, going for twice, 3 times. Sold. Thank you very much.
Big round of applause for Chris. Thanks very much. Also shout out to the super team, really doing great work. And we directly go on here. I really want to say thank you to all the partners and the Telekom HUBRAUM, of course, for letting us host here, really. And without further ado, introducing Martin from Avalanche. Make some noise for Martin. Where?
Hey guys. Thanks a lot for being here. Super excited. This is my first talk in Germany. I'm originally from Germany, but somehow I ended up somewhere else. So this is my first time in Germany. Super excited. I'm going to talk about Avalanche today. I'm really glad we had the Solana talk before, so we touched on many concepts already that will sound familiar now. And yeah, I will try to keep it very simple. Still want to understand a little bit of the crowd. Who here interacted with the blockchain already? So had some kind of wallet, send a transaction. Okay, so kind of like real. Okay, that sounds pretty good. Okay, so how we see the blockchain world is in 3 generations, right? Like, so the first blockchains were launched at some point, right? Like it was a single chain, single asset blockchain. There was Bitcoin, there were some before. There's also Zcash, right? Like you have one chain, you have one single asset. Then eventually there was an innovation with Ethereum that opened up the space to multiple assets now, right? We don't have only the native token, but now we have many tokens, we have NFTs, we have all kinds of real world assets. And how we see the next progression of this is multi-chain networks, right? So we have multiple blockchains in a network with multiple assets. So what that really means is we're going from a single blockchain with a fixed validator set to a network of heterogeneous blockchains with different validator sets. And at this point, you may be like, why, right? Like, why is Martin so good at design or, you know, like beautiful slide? No, what you're gonna ask is, why should we do this, right? Like, and the answer to this is independence, scalability, and compliance. And I'm gonna touch on all of these a little bit, and more than happy to answer any questions. But from these, you may already see we're heavily targeted at enterprise use cases, right? Like big financial institutions, government organizations, and all this. All right, so let's start with scalability. And I want to talk about blockchain performance. So in the previous talk, you already heard a lot about TPS, transactions per second, and everything, right? And when we think about the performance of a blockchain, I want you to go with this very simple analogy of a highway, right? So we have a highway, and each of the cars on the highway is a transaction, right? They all travel with the same speed. We're going to simplify it. And what does it mean to enter a highway? Means in our wallet, we're clicking send, and we exit the highway when this transaction is finalized on chain, right? Like this is written to the chain. It will never change again. We are finalized now, right? So this is our very simple kind of thought model here. We're going to stick around in my presentation. And we have 2 metrics here. And it can get very tricky when you enter the space because they seem very similar, but they're actually very different. The one is time to finality. I click in my wallet, right? We saw just with Solana very fast. I click in the wallet. How long does it take until the blockchain confirms that my transaction is finalized, right? Like I think we saw like around 2 seconds. Solana is one of the fastest, right? This time is completely independent of how many transactions my system can process, right? TPS, right? Transactions per second means how many cars can enter the highway at some point. It doesn't have anything to do with how long the cars are going to be on that highway, right? This is very important. And when we think about a blockchain, this mental model really helps and really makes us understand that these, you know, like can be very different. And when we build a blockchain, right, it's kind of like, what kind of highway do we want to build? So let's imagine we want to go from Munich to Berlin, right? What we want to build is a highway that goes the most direct route, right? Doesn't take any detours, and has a decent number of lanes, right? What we don't want to build is a single lane highway going through the middle of nowhere, passing through Paris, and you know, like it takes forever. It gets easily congested because it's only a single lane, right? So if we look at like blockchain systems out there, we see Bitcoin is from a performance point of view, and you know, we're just talking about performance, not about decentralization or anything else, right? Just the performance is a single lane highway that takes incredibly long, 60 minutes and easily congested. I think 7 TPS, right? I think we saw at Solana around 900 just a minute ago. So very limited use case. Ethereum is better, right? Takes only 15 minutes, but still not an incredibly high throughput because they are having 700,000 validators, right? Like, so they have to take compromises. Avalanche has around 2,500 transactions per second, right? The throughput, and a finality of below a second. So we could be happy with that, right? But if we think about 2,500 transactions per second is nothing. If we want to bring something like NASDAQ on chain, if we want to bring you know, many of the interactions we have today and where we trust systems in the Web2 world to chain, we will need a lot more, right? And now is the question, what are we going to do? Are we going to try to build that highway wider and wider and eventually even sacrifice some of our time to finality? And we at Avalanche think that we're not going to have a single chain anyway, eventually, but we will have a heterogeneous network of blockchains. So what does that mean, right? So we have subnets. The first one is pretty easy. It's a primary network, right? We take all the Avalanche validators, they validate a blockchain, that's a primary network. We have one blockchain, fair enough. But what we're going to do now is we're going to take a subset of the nodes of the Avalanche network, and they're going to validate a different blockchain completely independent of the primary network. And then we're going to do the same thing again, right? And nodes, a subset of the nodes on the Avalanche network are going to validate more and more blockchains, and these may overlap, right? A node may validate 3 or 4 subnets, but eventually we will see that, you know, like these subnets increase the throughput of the overall network by a lot, without, you know, like introducing additional complexity. We don't have to sacrifice short time to finality, right? Is that clear so far? I see some people nodding. Good, awesome. Cool, so this is the general idea of subnets, right? And we just saw kind of like how this, in our opinion, solves scalability, because now we don't have to introduce ZK or anything else, right? We can just scale with taking subsets of the validators. But there are like some pretty nice side effects that are interesting for institutions. So what we saw already, the fees, right? Like, so these are the Ethereum gas fees on the Ethereum network. And we see massive spikes here, right? Like usually it's pretty cheap, but on some days it just goes through the roof. And there are some times in the bull market where for many business use cases, this chain gets completely unusable, right? If you are, you know, like let's say you're a telecommunications company somewhere on the African continent, right? You can't afford that your gas fees just spike like 3, 4, 5x, because this will ruin your whole business model, right? Like we are also in industry with like, you know, margins that are not like 300%. So we really have to see that we isolate fees. We saw a very similar concept actually in the Solana. They have isolated fee markets. What we just see is when we have different layer 1 blockchains, these are completely independent, right? The idea of fees is if there's high network usage, fees go up to disincentivize people to issue transactions, right? It gets more expensive. Similar with flights or whatever, right? Like if we have these different blockchains, independent blockchains, each of them has an independent fee market, right? So if there is a lot of traffic on one subnet, the fees will go up. Other subnets are not affected at all. But also we have customizability, right? So let's think like we have a highway, but we also want to have, you know, like something where people can travel with a boat or with a train, right? While it's technically possible to build this all on one, you know, highway, you know, dig out one lane, fill it with water, put on some tracks, it gets very, very tricky, right? It is much, much easier to make these customizations in independent systems, right? So when we look at the EVM, we have a few modules there, right? Like we have the consensus layer, we have the execution layer, the EVM, and then the Solidity smart contract. Some of this you saw earlier today. If you look at the Avalanche stack, we have a shared consensus layer. Then we have different execution environments and different smart contract layers. And this is actually very, very powerful because now we can make easily some customizations to the EVM without, like introducing these customizations to the entire network. If you've had the pleasure of suggesting a change to Ethereum, this is a very, very lengthy process, right? Like you've suggested in the forum, you have to rally for it. You will eventually, 1.5 years later, if this comes like to the point where the community accepts it, you will be as lucky to have it included. However, it's always a compromise between the entire participants of the chain, right? Like because it will have to benefit everyone. If you're an institution, if you launch your own chain, you can do whatever you want with the virtual machine here. But it's even more powerful, right? Like we can see that we are completely VM agnostic. We heard some questions about the EVM earlier. Pretty good stab at the first virtual machine, I would say. There are definitely improvements, right? So we have a team, for example, if you're familiar with Aptos and Sui, they're building a Move VM in the Avalanche network. So on the same level, it's an interoperable chain in the Avalanche network running a completely different virtual machine. We could also see, actually, I would love to see a team actually building a Solana VM or some other VM because we think just the diversity of VMs is a really great strength for our network. And we already are having an internal team building actually a WASM VM where you can write programs in Rust. And then the last part, especially relevant for governments and institutions, is permissioning. And I want to be very clear, this is completely optional, right? We can do permissioning on many levels, validators, smart contract deployers, and users. And at this point, like sometimes, like people get up, leave the room, are like, we're on blockchain, what are we doing this for? It's for a permissionless world, right? And I believe that. And I really want the world to be permissionless and everything accessible to everyone. However, the reality is, many of the financial institutions we see today, many of the governments, they completely act in hiding. So I'd rather see them on a public, auditable blockchain with permissioning than in a completely closed-off system. And we think this is a good stepping stone to a future where we have, a lot more accountability, right? So what does validator mean, right? Like for some applications, let's say in the European Union, if you want to work with health data or whatever, you can't store this data outside of the European Union. So you can, for your subnet, permission the validators to all be in the European Union. And therefore you can be compliant, right? This is the first one. Another one is that you can permission who can interact with your blockchain, right? Who can deploy a smart contract. If you're a financial institution and you launch your institutional blockchain, you want to be very, very sure that not a random user is coming along and is deploying Tornado Cash to your chain, right? You can get in very, very, very big trouble. So also, if required, as I said, also completely optional, you can also require your users to go through some kind of KYC process to interact with your chain, right? And this way, I think we can enable many, many enterprises to, even now with a lot of regulatory, the situation is unclear, especially in North America and Europe, to stay compliant, move on chain, and then eventually open up as soon as the regulation kicks in. Yeah. So thanks a lot for listening. If you want to learn more about Avalanche, there's Avalanche Academy. Lots of free courses of what I just told you, but also more advanced ones, especially for the developers. Last thing I just want to chat about is Codebase, our accelerator program. So if you're building, especially institution, consumer-focused apps, we have an accelerator program, 2 badges per year. Every company gets a $50,000 stipend, right? This is not an investment, this is just to cover our living costs. And we accept around 15 companies. And then at the end of the program, there is a demo day and $400,000 of prizes to win. The first cohort is kicking off mid of March. Application closed last weekend. If you are building something with institutions, something with real-world assets, something with DeFi, come talk to me. If you already feel like ready to join this program, I can push you in last minute, but generally the next batch will also start in September. Awesome. Thank you very much. Happy to take any questions. Solana. Yes, this is the exact right question. What's the benefit of launching your subnet versus just forking Ethereum, whatever, Avalanche, whatever? Yes, interoperability. That's the right thing. So we think, like in future we have many chains already. I think more than I can count. I lost track a while ago. we think every chain will have to solve interoperability, no matter if they are in the Avalanche network or not. And the key thing here is to solve interoperability. Cosmos did it with IBC. We call our interoperability protocol WARP messaging, but yes, it's a trustless interoperability protocol, no additional bridge validators, nothing. It's all interoperable natively in the network. It's complete arbitrary messaging. So it's just sending bytes from one chain to another, and then all the applications, bridges, ERC20 can be built on top. But this interoperability protocol is completely VM agnostic, right? Like, so when we talk about, it's like we didn't build an interoperability protocol for tokens because we can't even assume that the virtual machine thinks that tokens are what we think in the EVM, right? Like, so it may be a completely different idea. The Solana idea of a token is quite different from the ERC20, and to give, maintain interoperability there, like, it's completely arbitrary messaging, and everything else is built on the smart contract layer. Yeah. For the interoperability layer? Yes, so it's literally just bytes are coming, and it's like kind of like think of a, what are these little things with where you stick your thumb on and like a telegraph or something, right? Like that kind of like the communication, that's a native communication layer, and then there are protocols building on top of it. But if you look at, like others like layer 0 or something, most of them work with a very basic communication layer, and then they're just messages being sent. For example, this user locked some tokens on the source subnet or source chain, wherever it comes from, and then some new token is issued on the destination chain. And usually there's a risk because these bridge validators can be tricked. But in Avalanche, this is all native communication, so no additional trust assumptions, no bridge validators, like that are running on some kind of personal laptop or whatever. We hope that people will use this more wisely than the other bridges we saw being hacked there. I think 1,200. Yes. Yeah. So generally, right, what you said, like the primary network, every validator runs it, very low computational requirements, right, like super low. Then the additional computational requirements come from how many additional subnets this validator runs, right? Like if they run 5 additional subnets, they can all be processed in parallel. So we can throw just, like RAM and cores at it. But in generally, actually, I mean, you're making a very good point and something that is highly discussed in the Avalanche community. Why do we require this validator to be part of the primary network? And what we're working on, there's something called ACP13. It's an Avalanche community proposal where some community members suggest that we allow validators that are not part of the primary network in the Avalanche network to run, because the reality today is to run a validator in the Avalanche network, you have to stake 2,000 AVAX, right? That's quite heavy, Like if you want to run your own blockchain, 10 validators, whatever, right? Like 20,000 AVAX. Not every startup has that lying around. So what we're talking about right now is introducing additional validators that are not, we call them subnet-only validators, that are outside of the primary network and are super cheap to run, right? Like very, very, very cheap. Basically no staking, maybe a bond of 100 AVAX or something. Get that. But we see in practice, right, like with reasonable hardware, 5 subnets per validator is the realistical limit. However, since it's only a subnet, right, like so with the current setup, we could run hundreds of subnets. But if we want to, go to a path where, basically unlimited subnets, we will need to enable subnet-only validators. Yeah, like a very limited, very limited. Like I think the cheapest AWS instance, right? Yeah, it's a very lightweight protocol. The main reason for this is that Avalanche consensus only moves if there are transactions, right? Like so, most enterprise blockchains have, you know, like let's say a couple hundred transactions per day, right? Nowhere close to like what you guys are doing in a split second, right? So the powerful thing about Avalanche consensus is that it only moves, you know, Bitcoin always moves forward, always computation, you know, like nothing happens on the chain, always moves forward. Avalanche consensus only moves forward if there's actually something happening. So if there's no transaction for 3 minutes, nothing, no computation, nothing happens. Primary network has no idea of what's happening on the subnets, right? Like it's completely separate. Yeah. Yeah. So currently every validator is part of the primary network. Every validator, and that's why they're called subnets. And with the discussion currently going on, we would also rebrand it because it's not a subnet anymore. It would just be an Avalanche network, I don't know, blockchain, whatever you want to call it. Like there would be additional validators outside of the primary network. But as of today, every validator running in the Avalanche network validates the primary network. We actually do have some enterprises that are like, you know, we are running our own Avalanche blockchain here. To be honest, we don't want to validate your public network, right? Like, this is a permissionless network. We're not touching that. So actually, they do have an option to kind of like light, you know, like light client style, not really validate the primary network, kind of just listen in, and so just as a kind of like additional compliance measure. But this will completely go away as soon as we have subnet-only validators. The C chain is part of the primary network. So yes, that's the native EVM chain. Yeah, and that's part of the primary network with the P chain and the X chain, which are a little bit more internal use, I would say. But the C chain, the main EVM chain that many will know. Yeah, but actually, like, so we talked about ordinals earlier, right? Like this weird idea of a very niche community, Avalanche ordinal/inscriptions community, or the community somewhere in China. We've never interacted with them before. They just like put a lot of traffic on our chain. And what we saw there was that the fees on the C chain spiked, and then we had a DEX that was running on a subnet, you know, low fees, below a cent. Great time. Everyone there was, you know, like cheering because they could just trade whatever was happening. And on the main on the primary network, we would see, you know, like transaction fees of a couple dollars, which was pretty terrible. Luckily, that passed. I think they burned like $50 million worth of gas every week, which I'm like, what the fuck? Yeah. Yeah. We didn't understand. Also, it just happened. We're very glad it passed. Niche communities. Okay, one more question. Let's go. Yeah, it's okay. So it's very fast. In a nutshell, right? Like, so what you're gonna solve to be very fast is consensus, right? You have to decide between conflicting states, right? And what we're doing is something called subsample voting, right? So imagine, you know, we have an election day, and you know, you see the results like 30 minutes, 40 minutes after the election office is closed. Like, how is this possible? It's possible by putting some people in front of the election offices and ask the people, hey, what did you vote for? And you're asking only a fraction of the people, like 3-4%, but you get a pretty good idea. Maybe not, you know, like the last, you know, like decimal point, but you get a pretty good idea. So what we're doing with Avalanche is when we have to decide between two statuses, that we're not doing a centralized voting or whatever, right? What we're just doing is a single validator just asks 5 random validators around them and is like, hey, what do you think? Is it gonna be A or B? And when they hear something back, they do this over 10 rounds. What's A or B? You know, just a small group subsampling. And when they see a very clear trend, they just log in and this way we can finalize below a second. So each of these rounds only takes a few milliseconds. Yeah, but I have a whole slide deck for this one, but I think my time is up. So yeah, this is kind of like the idea is subsampling voting, similar to kind of like the exit polls at elections. Awesome. Thanks a lot.
Any more questions? I like the 1, 2, 3 thing. That was good. Sold. All right. Thanks very much, Martin. One round of applause more for Martin, please, everybody. We're gonna have a short break of 5 minutes. Okay, guys. So there's just a short break. Grab a drink. Come back here fast. We have one last talk. Then we are preparing sushi over there. So be hungry. One more talk to go, and then we will have the live DJ set up, really amazing equipment. We will have great music in the kitchen, so you need to go through all 2 rooms. So yeah, then we will start drinking the beer, connecting, and I hope we can like get some really cool insights and connect everyone. Yeah, just in 5 to 10 minutes we will have the last tech talk here, so just refresh your brains, let it drip, take some Club Mate. Hey everybody, we're gonna go on with the last tech talk here of this incredible multi-chain event. So we invite you to take a seat and grab the last drinks. We're gonna have Bartolome from Hive. Exactly, I know, of course. From Hive blockchain, and I will leave the floor to you. I invite everybody to take a seat and grab your last drinks. It's the last tech talk. I know the brains are already burning a little bit. My brain, so much value, so much knowledge, so much new inputs. So yeah, let's fucking go.
Thanks. Hello everyone. I'm gonna keep it short. Hey, I'm Bartolome, and I'm running a witness on Hive. It's called Engrave, and I'm gonna be talking today about building decentralized application using custom JSON. When you think about decentralized application, you usually think smart contract, right? There was a lot of talks about smart contracts today, but this is not the only way to achieve decentralization. So let's think for a while what makes the application decentralized. So I believe the most important thing is that it has no central authority, meaning there is no one who could disable it or remove it from chain or from the internet. And it's usually egalitarian, meaning it's accessible to everyone. It's permissionless usually, and it's basically it should be free to use, let's say. And the third one, it's that its state is recoverable from a digital ledger, meaning that you can recover the state of the application from scratch, and each time you should get the same result. Like consider the voting application. You should be able to calculate the result of the voting, and each time you should be able to get the same result. And to simplify, I would say that the decentralized application should have a single place of truth, accessible to everyone, and you should be able to run the application on your own and should get the same result as everyone else. And you actually don't need smart contracts to achieve that. And actually, you know, every application contains some business logic. It's the set of rules that makes the application, determines the application behavior and functionalities. And usually you do it in the smart contract. But running smart contract on chain, like basically running every program on chain is expensive. We already heard today that it's expensive. And we would like to, you know, bring a solution that makes it as cheap as possible. And we actually have a solution that it makes it free for the end user. So consider the voting application again. So if you build a conventional app, it would look like this. You have a backend with API, with some endpoints that are capable of authenticating users, and getting some payload data to perform actions, right? So you should be able to create the poll, for example, and another user should be able to vote in this poll. And the payload to the endpoint could look like this. You can ignore the first line, but it should be basically simple object, simple JSON. So it's saying that it's the create action, and it defines the poll title, defines the ID of the poll, and defines the options available in this poll, right? So if the user wants to vote in this application, this poll, it should just, you know, send a simple JSON saying that I want to vote in this particular poll, and I want to vote on option red in this example. So what if you use blockchain, we can get rid of the authentication, right, from the endpoints, because we have authentication built in the blockchain, right? So every operation, every transaction is already signed by appropriate private key, and we're sure that it was broadcasted by, you know, the entity it says it was broadcasted by. And in conventional application, this backend that I was saying earlier would basically apply some basic rules, some business logic, some calculations, and it would put the result and the data, input data and the results in the database, right? So what if we keep the database part in the decentralized applications and the blockchain? So if we have a database, we could basically run a simple SQL query over it, right? And you know, every developer out there probably knows SQL. Like it's been with us like for so many years. And if you want to apply, you know, additional logic to this, you can just modify the query. If you have, for example, duplicated inputs, like the same user voting twice, you can just modify the query to ignore duplicates. So you can distribute the computation from smart contract and do not run it on chain, but you can run it in a database that are pretty good at doing some data, some computation of data. And this is how we do it on Hive, actually. Hive is an information sharing network. As a community, we forked from Steam almost 4 years ago to counteract the hostile takeover by Justin Sun. You probably know the guy. And yeah, since then, we've been doing steady progress. We've been introducing new features, new tools, and we've been building, we've been optimizing blockchain and been building apps that are off-chain working with blockchain data. The idea of using custom JSON, like storing the data on-chain rather than the data in a memory or running entire program on-chain, just store the simple data, simple JSON object on-chain, and build separate tools using this data is so powerful that some of our core features are built on top of this. Like I said, we are a social media network, and we have a following mechanism, right? So how to follow someone on Hive? You basically broadcast a simple JSON saying this account follows this account. And every API out there, like distributed and decentralized API nodes, will basically get the data and will return, for example, a wall with a post from this particular user. Every front end using every API will show the same data, and for the end user is basically free. There is no computation on chain, so it's basically super cheap. And on Hive, we have basically no fees, because most of things we do, we keep in a chain as data. And disk storage is super cheap compared to computation and RAM. But working with blockchain might be a bit tricky, because you need to handle, you know, forks. And blockchain nodes are pretty good at handling this, but if you want to index data, you need to handle this in your own application as well. And to make it easier, we just made a Hive application framework. So the idea of Hive is pretty simple. We have a simple, like a standard Hive node out there, and we have PostgreSQL database right next to it. And the Hive node contains a simple plugin that basically takes the block. Each time it gets the block, it pushes the data to the database, and the database contains an extension to handle all the edge cases that may appear. It tracks multiple forks at the same time. It can rewind state. It can basically handle all the states that are required by your application. And from your perspective, like the application developer, all you need to do is to run an SQL query against this database. Of course, like the fork manager is a bit more complex, because it also allows you to reply application on a working node, and you can run the node only for your data, like your particular JSON, or you can run also the entire big API node that handles all the application out there. But from your perspective, you can only run SQL queries to basically get the result of this example voting application. So so think about it. The only thing you need to know to build decentralized application is to know SQL. You don't need to learn new languages. You don't need to learn any new SDKs. If you know how to handle data in databases, you can basically run applications decentralized and distributed and free of charge for your end users. Yeah, and that's it. Thank you. I like to encourage all of you to join us on Hive and just try it. It's quite simple to do, and yeah, that's it. Thank you. If you have any questions, feel free. Nope. Then yep. So we are done. Yeah, thank you. Yeah. It's just we are working on a delegated proof of stake. So the consensus node is basically like the Hive node handles all the node work. Like the idea behind Hive and running decentralized application on Hive is that we have blockchain nodes running out there, and they are like they don't know even the fact that someone running an application somewhere else. Like those applications, you know, they do not impact the main chain. That's the idea. Like to make it so simple and so performant that we only keep data on chain, and you can read it and you know do whatever with it. Yep. Thanks.
Thanks very much. One big round of applause for Bartolomei. Thanks very much from Hive Blockchain. So guys, the brains are burning. We need a little refreshment. There are sushis in the other room if you are hungry. You just go down the tunnel to the right. And thanks again to Hive and all our other partners here. We're very excited. We're gonna have a more chill talk, not a tech talk afterwards. It's gonna be awesome. We will start in around half an hour, so you have time to take some sushis, connect with each other. That's what it's all about. That's why we are here for, to get to know each other, to exchange. And yeah, happy to have you here, guys. Enjoy. See you in a bit.